When people talk about internet speed, they usually throw around numbers without really explaining what they mean. You hear things like, my Wi-Fi is slow, or this plan is 100 megabits per second, but behind those numbers is a simple idea: how fast information moves from one place to another. At the heart of all digital communication is a tiny unit called a bit. A bit is the smallest possible piece of data, representing either a 0 or a 1. Every message you send, every video you stream, and every website you open is made up of countless bits moving through cables, airwaves, and servers. Today, we're breaking down internet speed from the smallest possible unit all the way to speeds so extreme they challenge the laws of physics. Bits per second. Bits per second, commonly written as BPS, is the most fundamental way to measure how fast data moves. A bit is the smallest possible unit of digital information, holding only two values, 0 or 1. Every digital action, sending a message, loading a website, or streaming a video, relies on massive numbers of these tiny bits moving rapidly from one system to another. When speed is measured in bits per second, it simply tells us how many of these bits are transferred in a single second. On its own, 1 BPS is extremely slow and not useful for modern communication, but it serves as the base unit from which all other internet speed measurements are built. Kilobits per second, or kbps. Kilobits per second, or kbps, represents 1,000 bits transferred every second. This was the first unit that made internet communication practical for everyday use. In the early days of the internet, speeds measured in kbps allowed people to send emails, load basic text-based websites, and exchange small files. While these speeds seem painfully slow today, they played a critical role in introducing digital connectivity to the world. Even now, kbps speeds are still relevant for devices that send very small amounts of data, such as smart sensors or tracking systems that don't require constant high-speed communication. Megabits per second, or Mbps, marked a major leap forward in internet performance. 1 megabit equals 1 million bits, allowing data to move fast enough for richer content. This unit became the standard measurement for home and mobile internet connections because it supports modern online activities like video streaming, social media, video calls, and cloud services. As internet infrastructure improved, Mbps speeds steadily increased, making the online experience smoother and more interactive. This is also where many people first encounter confusion because service providers advertise speed in megabits, while devices often display download progress in megabytes, which are 8 times larger than bits. Gigabits per second, or Gbps, takes internet speed into the high-performance range. 1 gigabit equals 1 billion bits, making this unit 1,000 times faster than Mbps. Gbps connections are commonly delivered through fiber optic technology, which uses light to transmit data through thin glass cables. At this level, downloading large files happens almost instantly, and activities like online gaming, 4K streaming, and cloud computing feel nearly instant. Gigabit speeds reduce delays and buffering, creating an experience where the internet feels nearly instant. Terabits per second, or Tbps, represents 1 trillion bits transferred each second. This level of speed is far beyond consumer internet and exists mainly within the infrastructure that powers the global web. Tbps connections are used in major data routes, including undersea cables that connect continents and massive network hubs that handle traffic for millions of users at once. These speeds allow platforms to stream content, store data, and provide services to users around the world simultaneously without interruption. Petabits per second, or PBPS, pushes data transfer into the realm of extreme-scale computing. 1 petabit equals 1 quadrillion bits per second. This level is currently explored in advanced research environments, where scientists test future networking technologies. PBPS speeds are essential for preparing systems that will support massive artificial intelligence models, real-time global backups, and next-generation communication networks.
At this scale, the challenge is no longer speed alone, but maintaining stability and accuracy while moving enormous volumes of data. Exabits per second, or Ebps, represents 1 quintillion bits transferred every second. While no existing commercial network operates at this level, Ebps is a target for future global systems. These speeds could support fully connected smart cities, planet-scale AI systems, and instant data synchronization across continents. At this point, traditional networking hardware begins to reach its physical limits. Zettabytes per second, or Zbps, represents a scale of speed that goes far beyond anything currently in operation. 1 zettabit equals 1 sextillion bits per second.
At this level, we're no longer talking about faster downloads or smoother streaming, but about handling all human-generated data at once. A ZBPS-capable network could theoretically move the entire global data output in moments. This unit exists mostly as a theoretical benchmark, helping engineers imagine what future planetary-scale communication systems might require as data creation continues to grow exponentially. Yotabits per second, or YBPS, stands at the extreme edge of data speed measurement. 1 yotabit equals 1 septillion bits per second, a number so vast that it challenges human intuition. At this scale, speed is no longer the main concern. Physical reality itself becomes the limiting factor. Concepts like quantum communication, light-based transmission, and interplanetary networking are often discussed in relation to YBPS. While this level of speed does not exist today, it represents the theoretical ceiling of data movement and hints at a future where information could be shared almost instantaneously across vast distances. Key takeaways. Internet speed isn't just about faster downloads or smoother streaming. It's a story of how humanity learned to move information, starting from a single bit and scaling up to mind-bending speeds that could one day connect planets, power global AI, and synchronize the entire digital world in real time. As technology keeps advancing, today's fastest connections will eventually feel just as slow as dial-up once did. If this video helped you understand internet speed in a clear and simple way, make sure to like, subscribe, and share it with someone who still thinks megabytes and megabits are the same thing. Thanks for watching, and I'll see you in the next one.